Hello and welcome to the NSF Retail Auditor Academy YUM FSCC Quarterly Development Training. During this training we will learn how to verify that the dish machine is properly working during an FSCC visit. When verifying the operation of a single rack dish machine, Standard 5.1 of the FSCC requires that the wash water temperature is greater than 49 degrees Celsius or 120 degrees Fahrenheit. To wash effectively, it is also important that dish detergent is present and stocked in the machine. It is even more important from a food safety perspective that during operation, the final rinse cycle of the dish machine properly sanitizes all food contact surfaces. Again, this is found in Standard 5.1. There are two types of sanitizing cycles found in a dish machine. First, the machine can use chemicals to sanitize. The most common chemical used is a chlorine-based sanitizer with an effective concentration of 50 to 100 parts per million. The chemical must be present and stocked in a machine for it to be effective. The second method used for sanitizing is heat. In a heat sanitizing machine, water is heated to 82 degrees Celsius or 180 degrees Fahrenheit or greater and sprayed over the food contact surfaces inside the machine. Most often, a booster heater is needed for the water to reach this temperature. Finally, as with any piece of equipment, we want to verify that the machine is in good repair. Any part of the dish machine that is not in good repair will be a deviation under Standard 7.3. Specifically, you want to verify that the gauges are working properly and that the booster heater is working if necessary. This picture shows a typical single rack dish machine that you will find in most YUM restaurants that have a dish machine. There are a few features of this machine I would like to point out so you have a better understanding of how it operates. First, you will notice that there are different racks stored on this shelf, and each rack has a different purpose. Different racks are used for washing items such as dishes, trays, pots, pans, and utensils. Each rack is made with a different configuration to hold items in a proper position for the water to contact all surfaces. Spend a few minutes learning what each rack is used for, and during an FSCC, watch to make sure it is loaded properly for washing. Next, the spray hose shown here is used to pre-rinse the heavy food residue off the surface of the items being washed so the machine can wash more effectively. Make sure the spray hose is not leaking and does not hang below the flood rim of the sink or drain board. Next, the full rack should be pushed into the machine and the door lowered to start the wash cycle. The necessary chemicals will usually be stored in bulk containers under the drain board as shown here. Chemicals such as dish detergent, rinse aid, and sanitizer, in the case of a chemical sanitizing machine, are fed through small hoses by a pump mechanism as shown on the wall in this picture. When working properly, the pump supplies the correct amount of each chemical to wash, rinse, and sanitize the food contact surfaces. Many times the machine will require a booster heater to raise the water temperature to a level required to wash and even sanitize in the case of hot water sanitizing machines. This can be seen in the picture as a metal box near the floor on the right. There's usually a red light indicating that the booster heater is on. Verifying that the heater is on should be the first thing you check if the machine does not reach temperature. From an operations and food safety perspective, the temperature gauges are a valuable tool for you, the YUM specialist, to use to identify that the machine is operating properly. The wash gauge, as shown here on the left, allows you to monitor the temperature of the water during the wash cycle. The rinse gauge, as shown here on the right, allows you to monitor the temperature of the final rinse cycle. This temperature is especially important in machines that use hot water to sanitize. We will be referring to these gauges in more detail over the next few slides. Now that you understand the basics of a dish machine, we can take a look at how to verify that the machine is operating properly. The first thing you want to do is ask the manager if the machine uses chemicals or hot water to sanitize. If the manager does not know, there are a few ways you can try to identify this for yourself. First, you can look for chemical containers under or near the dish machine. If you see a container of chlorine connected to a hose, this is most likely the sanitizer for this machine. If there's only dish detergent and rinse aid, most likely this is a hot water sanitizing machine. A machine that uses hot water to sanitize will have a booster heater. Look for a square metal box connected to the water supply somewhere under the machine. This should be the booster heater. The presence of a booster heater is not a guarantee that the machine uses heat to sanitize. A booster heater may be required to supply enough hot water for the wash cycle only. Once you identify the sanitizing method that the machine uses, have the manager or a team member run the machine through a full cycle. You may have to do this 2 to 3 times if the machine has not been used for a while. Running the machine for a cycle or two will allow the water to come up to full temperature and will make sure any chemicals are pumped from the containers. If you have identified the machine as a chemical sanitizing machine, and you've allowed it to run through one or more cycles, now you must know how to properly verify the concentration of the chemical sanitizer. Most chemical sanitizing machines use chlorine. You can always verify this by checking the label of the chemical container found under the machine or behind the machine. Once you are sure it is chlorine, run the machine through a full cycle. While it is running, have a chlorine sanitizer test strip ready for use. As soon as the rinse cycle stops, lift the door, wipe the test strip along the inner portion of the bottom of the door where the water is dripping. There will be enough chemical residual in this water to allow for a proper test. You can also place a bowl or a pan in a dish rack and test the water in the pan after the final cycle. Either way, after testing, compare your strip to the color chart on the test strip package and verify that it has between 50 and 100 parts per million of chemical residual. If your test strip shows less than 50 parts per million, run the machine through one more cycle and test the water again. If there's still less than 50 parts per million, this is a deviation under standard 5.1. If you feel comfortable trying to identify why the sanitizer level is not correct, a first step is to locate the chlorine supply hose in the container and follow it to the point of entry on the machine. At some point it will pass through a pump that feeds the chemical into the machine. Run a cycle and watch the hose during the final rinse. You should hear and see the pump turn on. While the pump is moving, look at the hose to see if you can see chemical moving through the hose. You may need to look for small air bubbles moving through the hose to verify the liquid is being transferred to the machine. If you do not see any chemicals moving in the hose, ask the manager if they know how to prime the pump. This usually involves a switch that activates the pump to draw chemicals from the container and through the hose. The manager should know how to do this, as it is usually required anytime the chemical container is replaced. If the manager does not know how to prime the pump, or the chemicals are still not reaching the machine, advise the manager to call for service. If you have identified the machine as a hot water or heat sanitizing machine, and have allowed it to run through one or more cycles, now you must know how to properly verify the temperature of the final rinse. Start by running the machine through a cycle. During the first part of the cycle, watch the wash gauge dial. Visually verify that the temperature reaches 49C 120F as required in the FSCC standards. You will know the wash cycle ends when you hear a click and the water briefly stops flowing before starting again. This next cycle is the rinse cycle. During the rinse cycle, watch the rinse gauge dial. Verify that the temperature reaches 82C 180F as required. If either gauge does not work and the dial does not move, mark this as a deviation under standard 7.3. If the gauges work and the temperature meet the requirements in the standard, you can assume the machine is working and continue with the visit. If the rinse gauge does not work, you will need to verify the final rinse temperature using some secondary method. If the rinse gauge does not work, you have two options to verify temperature. First, you can use a waterproof maximum reading thermometer as shown here. And second, you can use a thermo-label test strip to give you visual evidence that the dish machine is working properly. The first option, if you have one, is to use a maximum reading waterproof thermometer. To use this correctly, you must clear out any old data stored in the thermometer. While I highly recommend this Cooper thermometer, most manufacturers are similar in their operation. Push the mode button until the display reaches the max mode. Next, you'll need to hold the mode button until the display clears as shown here. Now you can place the thermometer in a dish rack. It is suggested to use the silverware rack because it has the smallest holes of all the dish racks. Most racks can allow the thermometer to fall through the bottom and get lost in the machine or damaged. It's also a good idea to place a second dish rack on top of the one with your thermometer to keep the water pressure from blowing it out of the rack. After you place the rack in a dish machine, run the machine through a full cycle. When the machine stops, remove the thermometer and read the display. If the thermometer display reads 71C 160F or greater, the machine is working and you can continue the visit. If the temperature is less than 71C 160F, clear out the display as before and run it through another cycle. If the reading is still low, record it as a deviation under standard 5.1. I'd like to take a minute to answer a question that I hope you have at this point. That is, why are you looking for a reading of 71C 160F and not the 82C 180F as the FSCC standard requires? The answer to this is actually fairly simple. The water entering the wash area of the dish machine must be 82C 180F. The gauge reads the temperature of the water while it is still in the water supply line. As the water enters the machine and sprays over the surface of the items being washed, the temperature drops. To effectively sanitize, the water that reaches the surface of the plate, utensil, or pan only needs to be 71C 160F. When you use the gauge to verify, you are checking the temperature of the water as it leaves the supply line. When you use a thermometer, you are recording the temperature at the surface of the items being washed, and therefore, the temperature only needs to be 71C 160F to be effective. The second option for verifying the rinse temperature is to use the thermolabel test strip. There are several suppliers of these strips, as shown here, but they all work in the same general way. In the strip is a temperature-sensitive material. This material is designed to register a color change at a set temperature. Typically, when the surface of the strip reaches the temperature that is indicated in the strip, the material will turn black, indicating the strip temperature was reached or exceeded. You cannot verify the actual temperature achieved using these, but you can be sure that the minimum temperature reached was the number that is on the strip. The various strips you just saw can be used in different ways. The T-sticks are made of cardboard, and the best way to run them through the machine is to place it in the tines of a fork, and then place the fork in a dish rack and run it through the machine. The second type shown here has an adhesive backing that you can stick to a surface. It is recommended that you use a metal pan or a metal bowl to get good heat transfer to the strip. This is not necessary, as any clean, flat surface will work. The last type shown here is designed to be secured to the handle of the dish rack. All of these thermolabels will provide you with a positive or negative reading for you to evaluate the machine. The strip will provide you with a visual validation of the rinsed water temperature by changing color or not. If there is any noticeable color change, assume that the temperature on the strip was reached. Sometimes the entire strip will not change, or may be slightly lighter than shown here. If the color change occurs, consider the machine to be working and continue on with the FSCC visit. If there is no color change, run the strip through one more time. If there is still no color change, record it as a deviation under Standard 5.1. To summarize, a dish machine must properly wash and sanitize all surfaces of the items being washed. As the FSCC specialist, you must verify the temperature of the wash and rinse cycles. If the gauges are working, trust the reading you get and document this on the report accordingly. If the gauges are not working, deviate for the machine not being in good repair and use a secondary method such as a thermometer or thermolabel to test the final rinse temperature. You should now feel comfortable with the basics of how to check that a single rack dish machine is working and know how to verify that the temperatures or the chemicals are at the correct levels. To make sure that you understand what you just learned, there's a short exam that must be completed. Please click on the link on the screen or copy this link into your internet browser. Log on using the username that was given to you when you took the original Auditor Academy training exam. This should be your first initial and your last name, as you see on the screen. If you forgot your password, please contact your lead YUM specialist or YUM account manager to have this reset. Good luck and thanks for listening.